Welcome everyone to day 3, the final webinar of a Botstiber Institute for Wildlife Fertility Control webinar series on mitigating wild boar conflict around the world and the potential for using fertility control. I am Monique Principe and I am the Managing Director of the Botstiber Institute. Today's agenda includes presentations on fertility control agents and the remaining challenges. And I would like to thank all of our presenters who agreed to participate and to all of our registered attendees. Similar to the last 2 weeks, we have over 100 registrants for today's event. We look forward to hearing your questions during our question and answer period that will take place in about 45 minutes. And please feel free to type any of your questions into the Q&A section on the bottom of your screen at any time. And I will now introduce the Institute's Director for Science and Policy, Stephanie Boyles-Griffin. Stephanie.
Hello again. I'm Stephanie Boyles-Griffin, and I serve as the Institute's Science and Policy Director. And as I have stated at the beginning of the other 2 days of presentations that we posted this month, this webinar series has been organized so that each session will build upon information presented in the previous session. So if you missed any of the sessions over the last 2 weeks, we highly recommend taking some time to view any sessions you missed prior to this session. We will make those recorded sessions available to registrants so you can watch them again or watch them for the first time. Monique, you want to introduce our first presenter for today?
Yeah, so our first session today is titled Research and Development of Fertility Control Agents. Our first speaker is Jason Brumer. Jason is project leader of fertility control at the U.S. Department of Agriculture APHIS National Wildlife Research Center in Fort Collins, Colorado. Previous to USDA, he was a professor at Colorado State University and continues there as a professor emeritus teaching courses in equine reproduction. He received both his Bachelor of Science and Master of Science degrees at Texas A&M University. And he received his PhD in animal physiology reproduction at New Mexico State University.
All right, I will try to share my screen and we'll go from there. Thank you for the introduction. So today, I'm going to try to present what the newest topics are in research and development of fertility control agents. We're working on several of these, not only here at the USDA, but with collaborators around the world. But I thought I would back up a little bit and remind everybody how we get to trying to find this magic contraceptive agent. I've heard from most of the speakers throughout the last 2 weeks that we're talking about, we're not quite there yet. This is what we need, but we're not quite there yet. And they're correct, we're not quite there yet, but I'm going to share why we're not there yet and what types of input we probably need. And that starts with the goals, right? The first goal seems to be obvious, that it's population control. I don't think anybody would argue with that. But within population control, we have lots of potential options. One of those that we don't think about a lot is, what if we just want to maintain the population? We're not trying to decrease anything, but just maintain that. Population control through contraceptive agents would allow us to do that. Clearly, we've discussed lots of means to decrease the population. In some cases, we've had discussions where they're hoping that fertility control agents will help eliminate a population. I think we all agree that that's probably not likely. And then I've got to throw this in there, coming from the background I did before, is that there may very well be, let's see, I've got the presenter view here. I'm not sure how to fix that. All right, good. Sorry about that. I'm glad I didn't have anything I shouldn't have. We may possibly try to increase populations, and there may be some strange thoughts about that, but we might be able to help increase predators, for instance, of a population that we want to eliminate. So I don't think all of these things are out of the realm of possibility. The other real goal is to mitigate damage. And I'm a firm believer that our fertility control agents might help us alter behaviors that are associated with all the things we've already heard about. The crop damage, the damage to the environment, the predation of livestock and other wildlife species, and certainly in disease transmission, particularly given that a lot of that disease transmission is related to the sexual behavior of the animals that are carrying those diseases. So those are the goals that we've got to keep in the back of our mind while developing new fertility control agents. The ideal agent qualities don't differ much from what we heard Kurt talk about the other day with potential lethal control. It would be ideal if they were species specific so that we didn't have to worry about them affecting any other of the livestock species that might be around. We have to be able to control the effectiveness. Again, the mind goes immediately to it's got to be 100% effective, and that's not necessarily always the case. We may want it not to be 100% effective so that a certain population is maintained for whatever reason. We also have to decide with that same thought whether this new agent should be permanent or should it be reversible. And that will play largely into how we develop an agent for fertility control. Convenient application, we've talked about that. Convenience doesn't always mean easy, but it may require that or help us decide which individual animals receive this particular agent. So anything from a hand injection, knowing which animals get it, to broadcasting something on the landscape that any animal that eats it might also be affected. So those are the things to think about. Clearly, we have to have minimal secondary risks. These are wild animals, and if they die and or when they die, or if they're hunted, making sure that these agents don't cross into the next generation. And then back to the original thought in mitigating the problem, we've got to make sure that these agents result in the appropriate behavior modification, or in some cases, we don't want them to modify behaviors. And so all of those are parameters and variables that we have to keep in mind when developing these new fertility agents. The next real question is, who do we target, right? We're talking about the wild pig here, and we have two obvious choices. We can either go after the male or we go after the female. And there's some advantages and disadvantages to each one of those. But this, again, with all the variables I'm talking about, hopefully describe why we don't have that magic agent just yet. Okay. As Monique said, I am a reproductive physiologist and a professor, and so I feel the need to make sure that we have all of the facts out here and think about what we are doing with the animals that we're trying to treat. So some basic facts and considerations. On the male side, remember that he's testosterone driven, not only in sperm production, but in behavior. And so that is going to potentially give us a target within a given sex if we go after testosterone or something like that. Let's not forget that the wild pig is amazingly prolific. The boar produces more than 16 billion sperm cells per day. And so when we're talking about affecting sperm production, we've got to be pretty serious in what it is that we're trying to get done. If we knock down the sperm production in a boar by 50%, that's still 8 billion sperm per day. Probably not significant enough to have much, if any, effect whatsoever. Remember that these animals mature quickly. These wild boars are producing sperm and mating as early as 3 months and probably no later than 5 or 6 months. And so their entire life, minus the first 3 or 4 months, they're reproductively active. And they are not a monogamous species, right? So the males are going to be mating with multiple females, and that will also help us choose which of these two to target. On the female side, they have two specific steroid hormones that drive what they do. Estrogen, which is what obviously causes them to be in heat and attract the boar, and then progesterone, which is the hormone that is going to maintain the pregnancy and her activities beyond that. Unlike the boar, the sow is born with all the oocytes that she'll ever have, which you're going to hear as I go through here is probably a good reason to maybe target that, because once we eliminate those or we can control those, then we're done. Versus the boar that, like I said, makes 16 billion sperm per day and continues to make new sperm each and every day of his life. The sow is polyestrous. That means that she will continue to cycle as long as she's not pregnant. And that's a bit of a problem in pigs, right? If we have an animal that's only monoestrous or has a very limited breeding period, then we know what to target. We don't have that advantage in the wild pig. Each of those estrus periods lasts 21 days, and so they come pretty quickly back to back. She carries the piglets for just shy of 4 months, and as a result has litters that will vary anywhere from 1 to 12 and maybe more than that, but I think on average for the wild pigs it's 4 to 6. And they have about 1.5 litters per year. So that is the reproductive facts that speak to why they are a problem and why reproduction might very well be one of our solutions. And so let's talk about what those targets could be. Right? This is a very basic cartoon of how the endocrine system, the hormones in both the boar and the sow work. It starts at the top there in the hypothalamus or in the brain, where GnRH, the gonadotropic releasing hormone, is produced. It stimulates the pituitary gland that we're all familiar with to make the two hormones FSH and LH. And in the male, which I have here, the FSH helps the Sertoli cells develop germ cells into sperm, and the LH drives the testosterone, and the testosterone does two things. It helps the Sertoli cell make more sperm cells, and it also has a negative feedback at the level of the hypothalamus to say, okay, we've made enough testosterone, stop. And so they have these pulses of hormones that go throughout their lifetime. And these pulses in wild pigs is about, in wild boars anyway, is about 3 to 4 hours. So this gives us two targets. If we could target testosterone production, we could do two things. We could eliminate the boar's production of sperm, and we would also eliminate all of the things that he does related to his breeding behavior. We could also potentially target just sperm production, and that's the bottom half of that screen where we're not altering testosterone because for some reason we want him to act like a boar but not make sperm, and we'll talk about that. The sow, we have a few more targets. This slide shows how a follicle grows from the primordial, which is what is already living in the oocyte, in the ovaries, until they become larger and larger and finally ovulate, and the egg becomes available for fertilization. And that's driven by the hormones at the bottom. And we'll talk about each one of those. So we could target follicular development. We could just potentially target ovulation. Or in some cases, we could target what happens after that occurs, and we could stop the maintenance of a pregnancy. So we've got lots of different places to look for that in the sow. Again, with so many targets, it makes it difficult to find that one magic one that's going to work for everything and everybody. So the mechanisms, some are fairly simple. Surgical intervention, we can castrate the boars. We could do, which would eliminate the testosterone production and the sperm production. So that goes to what I said to begin with. We could also perform a surgery where we do a vasectomy. That's going to stop the boar from making any sperm, but not affect his testosterone production or his behavior. Clearly, neither one of these are an effective use on the landscape, but while we're talking about mechanisms, I need to make sure that we include all of these. More realistic is the use of hormones, and by altering any of those areas that we just talked about, we could potentially mitigate some of the fertility issues that we have. In this slide again, we're talking about the boar, where we could use exogenous testosterone or even progesterone, the progesterone that the sow makes when she's pregnant. Both of these will downregulate the hypothalamus and stop the production of GnRH, stop LH and FSH, stop sperm production, etc. We can do the same thing for the sow. We can target lots of the different hormones. And again, just in keeping with what we're talking about, oftentimes we target progesterone production, which is this top line here. And the reason we do that is you see when progesterone becomes elevated, all of the other hormones, estrogen, LH, and FSH are all suppressed. And so it makes a really nice target as a means to contracept an animal. We've also got the use of immunocontraceptives. This is something that we work on a lot here. And in very basic terms, this is the ability to trick the body into building antibodies against something specific, usually something that the body is making and doing in order to keep that animal producing. We produce gonacon, right? It binds to GnRH and it stops it from stimulating the pituitary gland that we just talked about. And so in this case, the antagonist is the antibody. It binds to the GnRH. It stops it from initiating the behavior, the work of the pituitary gland, and reproduction stops. But there are other ones. A famous one, the use of porcine zona pellucida, which ironically I can't find has ever been used in pigs, blocks sperm binding. And what that does is it allows the animal to make an antibody against the zona pellucida. So it stops the sperm from binding to that egg, and it stops fertilization from ever occurring. Our newest immunocontraceptive, which is in the works here at the National Wildlife Research Center for other species, but might certainly be used in pigs, is what we call oocyte growth factors. We're determining ways to block communication between the oocyte and the cells around it so that these follicles don't grow and they can't ovulate. Another mechanism is the use of toxicants. This is a new product that's on the market fairly recently. It's called Hog Stop. This Hog Stop claims to negatively affect sperm production. It has all natural ingredients. The active ingredient on their label lists cottonseed oil, which really tells us that the active compound in here is gossypol. And we know that gossypol does negatively impact sperm production by inhibiting the steroid synthesis of testosterone. And so it may very well decrease sperm production. It probably will decrease the boar's behavior. But there's upsides and downsides to that as well, including the fact that it is reversible. When they stop eating it, then they can become equally fertile. And then finally, a physiologic interference, taking advantage of what the body does already. And this is really where our focus is right now. And so just as a primer here, reminds you that within the DNA, you have the thousands of genes. When a gene is functioning, it makes a messenger RNA. That messenger RNA gets into the cytosol of the cell and eventually results in the production of a protein. And that protein is what is the active part of what's happening. Because the body is really good at micromanagement and regulation, they make also these microRNA genes. These microRNA genes will help regulate what the gene has already done. So if the signal says we've made too much messenger RNA for the protein, can we stop it after it's been made? That's what the microRNA does. It binds to the messenger RNA and ultimately stops it from being able to turn into a new protein. This happens in almost every messenger RNA in our body. And so our idea is to potentially take advantage of that, specifically in the cell-to-cell communication. We know that the oocyte has to talk to the granulosa cells around it to make the follicles grow, to make it ovulate. We know that there is a specific RNA, and it's called microRNA 375, not a particularly clever name, but it alters the BMP receptor, or the receptor that knows what the oocyte is talking about. That receptor is a protein. This microRNA 375 is responsible for the production of that protein. So if we can turn on that endogenous microRNA, we can block the oocyte from talking to any of the cells around it, and we can stop growth of the follicle, we can stop ovulation. Okay, so the possibilities are endless. I haven't given you any answers because there are actually so many, and that's because there really are so many choices. So we're going to continue to work on specific agents for specific situations. And with that, I'll stop.
Okay, thank you, Jason. Before we go to questions and answers, we're going to have our next speaker present, and then we'll open it up for Q&A. So hold your questions or go ahead and submit them in the Q&A, and we'll get to them at the conclusion of the next presentation. So our next speaker is Giovanna Masai. Dr. Masai is based at the Animal and Plant Health Agency in York, United Kingdom. She is leading research and development on fertility control to mitigate human-wildlife conflict in the UK and overseas. She received her Bachelor of Science degree from the University of Florence in Italy and her PhD in wild boar ecology from the University of Aberdeen. Her research focuses on ecology and management of wild boar and feral pigs and on fertility control to manage wildlife. Dr. Masai published 2 books on natural history and management of wild boar and approximately 170 scientific papers and articles on wildlife management and behavioral ecology. She is also a board member of the Botstiber Institute's advisory board. So with that, I will turn it over to Giovanna.
Thank you very much, Stephanie, and welcome everybody. Today, I'm going to talk about a project that I am running in Hong Kong with my co-authors and co-authors of the presentation and colleagues, Doug Eckery of the National Wildlife Research Center in Fort Collins, in Colorado, US, and Paul Am Chan, that is responsible for the Agriculture, Fisheries and Conservation Department in Hong Kong, which is part of the Hong Kong government. Next one, please. So this is to remind everybody where Hong Kong is, where the red arrow is, more or less, should be a bit more on the left. On the bottom part of the slide, you have a map of Hong Kong. Now, for those that have never been there, Hong Kong is made up of Hong Kong Island, the famous island with skyscrapers, and a significant part of mainland. It covers about 1,000 square kilometers or 430 square miles. And on this, 7.5 million people live. So it's one of the most densely populated places in the world. And typically, wild boar and people come in contact, or wild pigs, sometimes I'll say wild boar, wild pigs. And when people see wild pigs, they'll take selfies and they'll start taking pictures. And that's partly where some of the problems start. Next one, please. We are all used to think about Hong Kong as a skyscraper island. In fact, it has the largest number of skyscrapers in any city in the world. Next one, please. However, 75% of Hong Kong are covered by grassland, woodland, and shrubland. Next one, please. There's an active campaign from the government of Hong Kong to educate people to, when they see wild boar or wild pigs, to do or not do some things, like do not drive wild pigs away with an object, do not feed them, do not approach them, pack away your food, and so on. The majority of people comply, some don't. In the picture, you see somebody feeding wild boar, which is illegal. Next one, please. Wild boar, wild pigs in Hong Kong are a native species, so they should be there. But there are a number of problems caused by the presence of wild boar, and these are traffic accidents. Some animals are aggressive towards people. There are hygiene risks when they feed from rubbish bins. They have the potential of significant environmental damage. For all of these, there are public complaints, and the government must address these complaints. So to address these complaints and to probably reduce the number of wild boar around, or wild pigs around Hong Kong, there are three possible options: culling, relocation, and fertility control. Culling is definitely not an option because it's publicly not acceptable. So we can rule it out immediately. Relocation is more publicly supported than culling, is obviously expensive, and it's something that the government is trialing now to see whether it works and in which context it might work. And the last part is fertility control. There is some surgical sterilization of young pigs, but immunocontraception through Gonacon, and I thank the previous speaker, Jason, for explaining what Gonacon is. So there was some, people felt that we could try immunocontractives, injectable immunocontractives, to see whether it makes sense in a context like Hong Kong. Next slide, please. We started the project in 2017, and the first aim of the project was to test the contraceptive effect and the feasibility of delivering 1 or 2 doses of 1 ml of Gonacon in free-living wild pigs. We also wanted to monitor patterns of reproduction in wild pigs, and we targeted females only because these are the ones that really drive numbers and population growth. This project was based on the fact that we had tested, as I mentioned in my first webinar, we had tested Gonacon in captivity. It had fantastic results. 11 out of 12 animals injected with 1 dose remaining fertile for at least 4 to 6 years or more. We then started the second, so I'll briefly talk about the preliminary results of phase 1, and then we have just started phase 2, where we have increased the dose, and I'll explain why. And we're also monitoring the effectiveness of Gonacon in terms of antibodies to the vaccine, and we're monitoring the effectiveness by using attractants and camera traps. The data collected every time the field team traps an animal are age from tooth eruption and replacement, body condition scores, reproductive status. We look at whether the animal is pregnant, lactating, lactated, or flat. I'm happy to discuss this later if anybody wants. We collect serum for antibody titers and for progesterone, and we look at the recapture success. All the animals cannot be marked individually apart from equipped with a microchip. So they have a microchip inserted behind the ear. Next one, please. Some preliminary results. So the total number of animals pregnant or lactating in blue peaks in March, as in many other populations, certainly around Europe, but it's widespread everywhere. There are pregnancy recorded throughout the year. Next one, please. In terms of effectiveness, we had 16 recaptured wild pigs out of many, many tens captured, but we only had 16 recaptured that were treated originally with Gonacon. Of these, we regarded Gonacon as effective in 7 animals, recaptured between about 200 and 740 days after the first dose. In 2 animals was not effective, at least when they were recaptured 260 or up to 2 years after vaccination. And for 7 animals, it was too early to assess the effect. We also found that vaccinating pregnant sows does not affect ongoing pregnancy. And we also found, like in other species, that there is a threshold we call high antibody titers. If some animals have a higher level of antibodies above this threshold, we are pretty sure that they are not fertile, so the contraceptive has had an effect. Under that threshold, anything can happen. So we can have animals that are pregnant or cycling or are still infertile. Next one, please. We also found early reproduction, pregnancy and cycling in 11% of animals under 1 year old. This is unusual for the wild boar, free-living wild boar. We then decided that if we were recapturing animals given 1 meal as a primer, as a first dose, we would give them another 1 meal dose to boost the effect of the vaccine. And then in phase 2, all the animals captured will receive 2 meals, so a double dose. We have some preliminary results that suggest that the antibody titers are higher in animals injected with 2 meals. And we have a fantastic team of vets with us that are doing, whenever an animal is captured, that means surgical sterilization through tubal ligation for all the animals under about 85 kilos of body mass. Next one, please. So the preliminary conclusions are that gonacon is likely to be an effective, safe contraceptive in most sows. Remember, we're talking about effect on individuals, not effect on populations yet. Recapturing gonacon vaccinated animals has proved to be challenging. And so we are exploring other methods to assess remotely the effectiveness of contraceptive. So for instance, we're using site attractants. We just published a paper, or have a paper accepted on how to attract these animals to sites where we can monitor them through camera traps by reading, also having readers of the microchips. And we are trying to implement these to follow this animal throughout for many years after they've been vaccinated. The last thing I would like to say is that I believe Hong Kong is a glimpse of the future of many cities in the world. It's a place that one could call overcrowded by people with strong views on how to manage wildlife and wild boar or wild pigs, and by a lot of wildlife is subtropical, and there are a lot of species, and so these conflicts will continue, and that's, I believe, where a lot of other places around the world are going. Last slide, please. This is just to thank the Agriculture, Fisheries and Conservation Department for funding the study, and my co-authors in particular, the Wetland and Fauna Conservation Division of the AEFCD, and the team of vets at Ocean Park Conservation Foundation. And also I'd like to thank the Botstiber Institute for Wildlife Fertility Control for inviting us to share the preliminary results of this study. Thank you.
Thank you, Giovanna. Okay, so now we're going to start the Q&A session for the last 2 presentations. So if you have questions, please submit them through the Q&A option at the bottom of your screen. I think we have one to start. So this one is for you, Jason. Are you with us?
I am.
Okay,
Yep.
great. Okay, so the first question is, for comparative purposes, how many sperm cells do a human or other livestock species produce a day? Is 16 billion a day unique for a mammalian species like wild pigs?
Yeah, great question. Compared to people, it's astronomical. And compared to other livestock species, it's quite high. Probably the lowest daily sperm count for livestock species in general is the horse. And we also know that they're highly prolific. So the boar is among the highest and most efficient at producing sperm.
Okay, thank you. And then while we're waiting for some other questions to come in. I have one. So you mentioned with porcine zona pellucida that there weren't any studies on pigs. I'm wondering if the reason is because if you injected porcine zona pellucida into a pig, they would not react to it because it's a porcine protein. And so if you're injecting it into a pig isn't going to respond to it the same way that another species would. Is that correct? Or
it's a good thought, but no. That's why I said we tricked the body into doing this, because GnRH is also normal in all bodies. And so in Gonacon, we're tricking them into to attacking GnRH. We would do the same thing with, it's actually ZP3, we'll get technical. It's that zona protein. And that zona protein itself is very common across all, not all species, but most.
Right.
And so that's why we put these in an adjuvant, is that the immune system comes, and if this is close enough to it, the cells see that and say, oh, this cat's got to be a problem also. I just don't think it's been used in pigs, because when they developed PZP, pigs weren't the problem that they are now. They weren't taking of immunocontraception. And pig ovaries are quite easy to get from the slaughterhouse.
Right.
So yeah, we've talked about why this hasn't been used, and I think it's kind of silly not to try it.
Well, and but the other thing that we run into is that it would require an injection, and in a lot of the applications that we're talking about, maybe not Hong Kong, but some of the other ones, it may not be logistically feasible or preferable for the end user, the farmer that's having problems with these animals rooting crops and things like that, where they don't want them to remain on the landscape. And if they had one in hand, they may not want to inject them with something and then let them go. But if they could feedily, then as part of an integrated approach, that might make sense. But yeah, I'm glad that I asked the question, because I actually wasn't sure why that had not been. Okay, so let me see if we have a few more that have come in. So far, I don't have any that have come in yet. So just the one. I hope that this is updating the way it should. Monique, do you see any questions on your end? I just want to make sure it's not just my computer.
Not yet. No, I do not. I think what you're seeing is all of it.
Okay, well, we'll hold on for a couple of more minutes since we have plenty of time. Our speakers were very efficient this morning or this afternoon or evening, wherever you're joining us from.
Whilst we wait, Stephanie, I do have a question for Jason.
What?
So Jason, Lowell Miller, that produced Gonacon, suggested to me, when I asked him why this has not been, PZP has not been tested in wild pigs, he said to me, because it will not be recognized as self, as Stephanie was asking. And then, but your answer seems to suggest that that's not the case. That's why you put an adjuvant with it, to make it non-self. But maybe it's worth, I don't know, there are different types of PZP, correct? So I was wondering whether it might depend also which PZP has been used in the past.
Potentially. I would say that shouldn't matter, because all of them will have that specific protein ZP3 in it,
right?
Regardless of the source. I'm thinking also maybe another reason it's not used is because of that. It is a biologic. It's not a specific agent. And as you know, with Gonacon, we actually synthesize that protein. And so we know exactly what's in there, and that's the only thing that's in there. And so that may be something from a regulatory standpoint that, would be hard to get, certainly across international borders, if you're taking.
No, you're right.
From one country to another.
Yeah, that has just reminded me that some people, I don't remember whom in the world, told me that they were unable to import PZP because it was derived from, it had an animal product in it.
Correct.
That I believe that is correct. And it's one of the reasons that there are folks, some of which that may be joining us today, are working to develop a recombinant ZP that will not have those issues, the biologic issues associated with them. Because that's the thing, is that in order, I think the reason that it's produced in a separate lab in South Africa for African elephant applications is because it can't be transported from the Science and Conservation Center in Billings, Montana to South Africa or India. Same with India. I think India produces their own, or is going to, if the government will allow them to use it there on animals like Asian elephants and other animals. So let me look and see. It looks like we do have a question, another one. So this is for either of you, Giovanna and Jason. How far out timeline wise is an oral pig population control from development, do you think?
I'll let
Jason,
you answer that.
Sorry?
He just threw you under the bus, Gio.
That's fine. I'm happy to go under the bus. So I think the question, you should split it into two parts. One is, which I always say to everybody, even if we had an oral contraceptive tomorrow, then you will have to register it and to test it in several contexts to see whether it does what it's predicted to do through a model. So the delivery of all these drugs is often not taken into account. So that's the first part. The second part is that we are working on a very big project on developing oral contraceptives for grey squirrels, the American grey squirrels that in the UK is a non-native species. If what we are doing works for grey squirrels, I'm pretty sure it will work for wild boar too. If it does work for wild boar, we'll have to start everything all over again, because obviously it's a big set of other trials and so on. In Europe, to bring something to the market takes 3 to 5 years and about 3 to 5 million euros or dollars.
And I would add to that, if we look at it in the purest sense, we already do have oral contraceptives available, but because of all the things that Gio just talked about, we could put out oral progestins and oral anything steroids would be suppressive of fertility, but it would do that to all animals, and you wouldn't know which ones got it, and they would have to ingest it constantly to do that. And so those agents are available, and they're used in other species, humans, but we can control those a whole lot more that way. The Hog Stop that I just told you about is an oral contraceptive.
Right.
So they're there. They're just, again, it's that magic one we're all looking for. And that one doesn't yet exist because I don't think we all know or agree upon what we want.
Right.
Jason, if you put, let's say, wild pigs on the pill effectively, what would happen to the people that eat the meat of those animals? Will it be affected?
It depends on how much, but it shouldn't be any more than eating a pregnant sow, right? They have high levels of progesterone anyway.
Okay.
But yes, steroids will cross, and that's, it is a concern, more of a concern in the environment to have just those out there. But yes, good question.
Jeanette, you had your hand raised and had a question. Do you want to unmute yourself and ask?
So actually, I decided to just take notes and address some of these when I give my presentation. So it was just comments, not really questions, but thank you.
That's fine. No, that's completely your discretion. So let me check and see if we have any more. If we don't, we might want to go ahead and move on to our next two presentations. And that would give us more time at the very end of the session and the workshop series for any overall questions that people might have about the presentations today, or any of the presentations that people may have viewed at a later date. So if no one has any other questions or comments, I'm going to hand it back over to Monique.
Okay, both our speakers for our next session are with us, so let's begin. Session 2 is titled Remaining Challenges, and our first presenter is Jeanette O'Hare. Jeanette O'Hare is the manager of the registration unit at the USDA National Wildlife Research Center, a position she has held for 7 years. The registration unit is responsible for planning and implementing regulatory data development plans to support the Environmental Protection Agency, the Federal Drug Administration, and the U.S. Department of Agriculture regulatory approval of wildlife damage management tools. Prior to becoming manager, Jeanette was the NWRC registration specialist for 10 years, and before coming to NWRC, she worked for the Texas Department of Agriculture Pesticide Division as an environmental quality specialist, primarily responsible for evaluating the fate of pesticides in air, soil, and groundwater. She also worked as a research specialist at the University of Arizona, Department of Pharmacology and Toxicology, and Jeanette earned a Master of Science degree in Biological Science from the University of Nebraska and a Bachelor of Science in Biology from the College of St. Mary, Omaha. Hello, Jeanette.
Hello.
Okay.
Thank you for that
And
introduction.
It's all yours.
So yes, I'm going to talk about some of the challenges, sort of beyond the research challenges in themselves for product development. And I want to talk a little bit about my title, which was originally, Wouldn't It Be Nice If Only Pigs Could Fly? And this comes from an interaction I had like 30 years ago. And it had to do with someone I was at a conference and someone was working on development of a drug. And they're really in the early stages, and their perception of the likelihood of it ever making it to market was that it would happen when pigs fly. That wouldn't happen before. So that's kind of I think, a philosophy that some people have that maybe aren't familiar with the regulatory process. So I would kind of like to dispel that myth and kind of switch to a more slightly optimistic view, in that really the regulatory paths and the research paths in general are all really opportunities that do come with challenges, and then focus a little bit on how to manage those specific challenges. So pig contraceptive would be regulated. It's considered a regulated product. And, the question might be, in the US, at least, who would regulate this kind of product? So prior to 2006, FDA was the regulatory authority for contraceptives used in animals. And there's a little bit of an exception to that, but generally that's the case. And in the regulations, there are criteria that determine who actually registers a product, and EPA has a similar kind of set of criteria. And these next two bullets here are not the only things that are considered, but there are two of the primary ones. So if a product's intended to diagnose, treat, or prevent a non-infectious disease or symptoms, then it's regulated by FDA, but that is not a product, that's not the criteria that would determine whether or not a contraceptive could be used in pigs. And then the other primary criteria is if the product is intended to change the structure or function of a vertebrate animal for any other purpose, which is pretty broad. And that's where FDA received their authority to regulate contraceptives. Then in 2006, or probably a little bit before 2006, EPA and FDA jointly decided that contraceptives that are used in wild and feral animals really should probably be registered and regulated by EPA. And again, in the regulations for EPA that help lead them to this conclusion is that anything that's used to mitigate a pest would be in fact regulated as a pesticide. And the definition of pesticide is really broad from a regulatory standpoint, because it includes repellents, and other not intoxicants and other types of products, and not just pesticides that we usually think about, and even antimicrobials, right? So EPA has been pretty involved right now with trying to register new products for cleaning, homes and things like that with the COVID pandemic, cleaning surfaces. So that means, in this case, anything that would sterilize or contracept a wild or feral non-captive vertebrate pest would be classified as a pesticide. So this did have a few challenges with it because some people weren't happy with deer or horses, for example, being classified as pests. And that actually was even a little bit difficult for perhaps even attracting funding and things like that, or partnerships that might involve, say, nonprofit organizations, because they were in some cases concerned about their donors not being on board with them perhaps being involved with or promoting a pesticide, even though it was a contraceptive and not really a toxicant. So there was some challenges with that. The opportunity, I would say, is that I think the EPA regulatory process fits in terms of the data that's required for an environmental use across the landscape that we are usually looking at with these contraceptives, and would be the case for a pig contraceptive. Now, how do other countries regulate it? I can tell you they don't consider it a pesticide. That's a little bit unique in the US. And part of the reason in the US, our regulations are based on the fact that it's the intended use of the product, it's not the formulation. So the idea of a vaccine being a pesticide is a little difficult for people to understand, but it's because it's based on what you intend to use it for. So if there's anyone from, we get requests occasionally for Gonacon in particular to use it in research or to develop it for approval in another country. And in those cases, because the data requirements are very different than FDA's, we can't really help them a lot with some of the data that they might need. One, to import the product into the into another country. And then even if when they get to that point, we really don't have a lot of data to help support them with their registration or drug approval process in those countries, because the data just don't line up correctly. So back to the US and EPA, this table shows some of the data requirements in terms of the category they're in. Now, each one of these has a total of, from just a few to maybe 15 or more data requirements. Now, they're not all required for all kinds of products, and toxicants require more than others. But I wanted to show you some of the categories here, the general categories of what you might be looking at for an application method for a pig contraceptive. And the check mark indicate that there would be data required in those different categories of data requirements. So a ground application would include more data than, say, a bait station or an injectable. So this, of course, impacts your timeline and your costs for data development for a registration product. And these are all very, I would say, general categories, and this is all going to be very much product specific and based on not only the design of the product and what it's intended to do, but the application technique, and the data requirements are intended to assess the product efficacy, human health, and environmental risks. And it's possible to get waivers from some of these data requirements. Some just don't apply, but some you can obtain waivers on a case-by-case basis if you can provide good scientific justification for those waivers. One thing I do want to talk a little bit more about is this food residue issue. And that came up in our question and answer a little bit. What are the impacts on human food? Now, for Gonacon and I believe Zonistat, there were really no food residue questions from EPA on this. But recently, in the last couple of years, EPA has, I think, for the first time, considered a pesticide product in a wildlife species as being a product that has a food use. And that species was pigs, so wild pigs. So there is precedent for that. So just to follow up on that discussion, that is something that, have to think about and would be good to consider because, I mean, those data requirements are fairly expensive. Most of them are on the end use product. I'm sorry, most of those are on the active ingredient, not the end use product. But, they could easily reach and approach up to $2 million without too much trouble. So that would be something you would have to really talk to the regulatory agency, in this case EPA, to see how they would address that. So in your planning process, though, you can be thinking about, is there something you could do to avoid that, right? So one of the things might be, if it's oral, is it possible to add a dye, right? So, and maybe that would satisfy EPA, maybe. The other thing is for an injectable, we've recently revised our Gonacon label for deer to allow, it was originally hand vaccination. So now it allows, the first dose has to be hand vaccinated and the animal's marked. And then the second dose can be administered remotely by DART. And so that marking the animals with an ear tag or something like that, that said perhaps, do not consume or something that would indicate that if a hunter, took a pig that had perhaps, been dosed, then that would be a way to indicate, and to alert them that they shouldn't consume it if that's in fact a concern. So the other part is it might not be a concern, as Jason pointed out. It just depends on the product. So that previous was for a brand new use. Now, if you already have an existing product and you want to use it on another species, or you have an existing product that you could modify a little bit to use on another species, then this is what your data would look like. So because all of these things that are indicated as existing, those specific things you would have already done when you registered your first product. So all you have to do is cite those data. So that's quite a relief in terms of regulatory burden and with respect to cost and the timelines. So, and again, depending, like in this bait station use, for example, you might need a little bit of data if you have, and we're talking about pigs. So if you have bait spillage or something like that, you could have some non-target effects that you want to be mindful of, and there might be data required for that. But the main thing that's definitely required would be the product efficacy. But that's a pretty low bar, and this is a really, if you can do this, this is great because it just really saves you time and money and gets you a tool available first. And of course, the food residue, what I said on the new product would apply here too. It may or may not. If you had to do it on the original product, then you could cite it. But if you hadn't done it, if it wasn't something EPA would consider a food use, then you would have to generate that data if it was required. So this is just a little bit about managing regulatory timelines, costs, and especially expectations. This table has just a little sort of general broad categories of like a new product versus using an existing product for a new use. So you can see the timelines are quite different. I would say from my experience, we're looking at, often 10 to 15 years if you have a brand new product that's really a brand new technology. And then the cost can be quite high as well. Now, contraceptives are a little bit, I would say, lower regulatory costs and fewer data requirements in general, but it still can be quite expensive, especially if you end up in that food use category. And the new and existing, or using an existing product for a new use, like a new species, that timeline, of course, is much shorter because you can and less expensive because you can cite that other data. Just a couple points about the R&D. I have sort of included a little bit of that information sort of in my estimates here, but again, if you have a brand new technology, those costs and timelines can be quite a bit longer. It would just depend. And a lot of it is, like in this timeline, I said, is at least half of it in many cases is the regulatory data development time, and then EPA's review time is important. That, like for a brand new product, for EPA to approve a registration once you submit your registration application, can be 24 months. And so they have literally 2 years to review it when you're all done with everything. And hopefully you're done and they don't decide that you need some additional information. And this picture, I just put this in here for illustration purposes. Now, I wouldn't expect this for a contraceptive, but this is the last paper product application that we sent to EPA in paper form. Now everything's electronic. And full disclosure here, EPA at the time required 3 copies. So this is 3 copies of that data submission, but it just gives you an idea of how much can be involved. And I can tell you, you know, the GonaCon submission in 2007, I think, was much, much smaller than this. It might, if you can see my pointer, it might represent something about that thick, double-sided. And these are all double-sided, these data requirements. And this one, again, this was for a toxicant. But if you have to start delving into food use data, those reports are quite large and complex studies. So that can really add to your time and costs. So planning, this is something that I kind of feel kind of strongly about. So Dwight Eisenhower said, at least a version of this saying, he's been credited with a few different versions of this, but basically that plans are useless, but planning is indispensable. And I've definitely found that to be true. If you're not planning and thinking about the entire product development process, it can really, I think, hurt you in the long run. Part of the planning process, I mean, I was really glad to hear Jason talk about what some of the goals are for a product. Do you want it to be permanent sterilization or not? So that's all part of that research and thinking ahead, which is absolutely critical in my mind. In addition to that, there are other factors here, and I kind of consider all of these important, so I just put them in alphabetical order and not in any other sequence. But you know, and I did hear discussions too about what's the application technique? How are you going to do that? What are going to be the costs of the product to the end user? What's the cost for the research and development? What's the cost for the data requirements? If you have go, no-go points, I would, I guess, implore people not to just pass them by and actually stop and look at them and see and make a decision, right? Make a decision whether to go or not and not ignore them, which happens sometimes. What is the problem you're trying to solve and what's the use pattern? Again, even deciding the regulatory path and being aware that it could change. It's unlikely, but I think we're set now with it being EPA in the US. All of the research and development and scientific research capabilities that go into just designing the product. Can you scale it up? And again, these aren't in like they're only in alphabetical order, but what is your plan for solving it? What's your solution? And don't forget about stakeholder needs and checking in with them because they can change. They may want something different than what you started out with. Sorry about that. Working from home, have the dog.
All right.
The other thing is there may be some technology transfer issues. If you have a collaborator agreements, are there any patent issues? Are there already existing patents you need to be aware of? Is there potential for new patents? And always timelines. And then just in the end, is it really a usable product for the end user? So they're all important. And I think there are other additional things to consider that I haven't thought of that would be product specific. And that the generally, I think the common sort of analogy is like a pipeline. So you sort of put something in and get something out. I kind of like more of a circle sort of analogy, in that you start with a problem and eventually you have to develop a product that comes back to solve that problem, right? So you need a solution. So you need to kind of close that loop. And I think all of those considerations that I just mentioned, and the ones that examples of what Jason mentioned, are really all very integrated into that system. They're not separate entities. They're certainly not Legos. Sometimes there's a tendency for, in some of these projects, where people kind of want to put them all together at the end and hope everything works out. I think you really have to be cognizant of all of those issues as you're going through that development process. And I'll just add with one thought about being aware of unforced errors. There's a lot of things that you can do to set yourself back. And this is a cartoon I found that actually was in reference to institutional inertia, where you just can't seem to change, even though maybe things aren't going the way they should. And if anyone's on their phone and can't read this, it's a woman pointing to one of her sons who's developing the wheel and saying, all you've done is chisel all day. Do something useful, like helping your brother drag those rocks up the hill. So if you find yourself dragging rocks up the hill, just remember it's okay to change. You might have to change course, and just don't stick with it for the sole reason that you have so much invested in it that you can't really turn around. And there's all kinds of other errors and things you can do. And there are things that, you know, you can think about in terms of developing a product in a way that helps you also address some of those regulatory questions. Because otherwise you might be in a situation where you answer the research question, but it's not exactly the same as EPA's question, and you have to do almost, you know, a similar study over again. So if you can sort of, you know, work and think about that regulatory process as you're developing your product, that will, I think, in the end, save you time and money and perhaps headaches. So with that, I think I will end. And if I guess we'll wait for questions until we've heard from Doug. So thank you very much.
Thank you, Jeanette. That presentation was excellent.
Thank you.
I especially like the list of considerations before you even start down the path or the pipeline, as you say. Everybody gets really excited. I think you said at the beginning of your presentation, managing expectations. That's a lot of what the Institute is devoted to doing. And one of the reasons why we're having this webinar series is just for that reason. I don't think a lot of people realize from start to finish how long a process takes. And that's after you actually have a product in hand that you think works. That's not even including the time that it takes to figure out whether it does or not.
Yeah,
so
you're right.
Really, really amazing. Thank you so much. Okay, so our next presenter and final presenter is Douglas Eckery. Dr. Eckery is an assistant director for the National Wildlife Research Center at the U.S. Department of Agriculture. He was the project leader for the NWRC's Contraceptive Technologies for Use in Wildlife Population and Disease Management project. His research is aimed towards the development of new methods of fertility control that can be integrated into wildlife management strategies. Dr. Eckery spent 17 years in New Zealand researching the reproductive biology of the brush-tailed possum and in investigating methods of fertility control for this species. And he played a key role in establishing the National Research Center for Possum Biocontrol. He is an adjunct faculty of the School of Biological Sciences at Victoria University of Wellington in New Zealand, and the Department of Biomedical Sciences at Colorado State University, where he is also an affiliated faculty of the Animal Reproduction and Biotechnology Laboratory. So with that, Doug, I will hand it over to you.
Thank you very much, Stephanie. And thank you for this opportunity, and thank you for everyone who's joined this webinar series. And in particular for today. Well, again, thank you for that introduction, and glad to be here today. Let's see if I can get to the next slide. Did they go to the next slide?
Perfect.
Right on. Okay, thank you. So this was about the remaining challenges. And I guess the huge challenge that's just staring at us is there's too many pigs. And whether they are an invasive non-native species, as they are here in the United States, or whether they are in their native habitat. And I've shown a picture there of some of the wild boar that we've worked with in Hong Kong. There's just too many of them, and that's why we're having this webinar series, because they are creating lots of conflicts in many different ways and contexts around the world. Throughout the presentations or this webinar, we've heard them described as being intelligent, adaptable, and certainly highly fecund, which adds to the challenge of trying to manage this species in all these different habitats and the different contexts. The current methods of control, the primary methods that are available, of course, are trapping and shooting. And some of the presentations showed where they can be effective, but they're limited in the extent that they can be effective. And they're not the solution either, as we've learned. There are some poisons available here in the United States. One has been registered. We're trying to register the other one that Kurt Vercauteren talked about, sodium nitrite. And in Australia, we heard that there's some other toxicants there that are being used as well. But they're not widely available and certainly not being used globally to manage the pigs in these different contexts. This is a headline from Gail Kern, one of our public affairs specialists at the USDA. And as you see, it says we can't barbecue our way out of this, which again is kind of saying that this trapping and shooting is not the way that we're going to find our way out of this. And it does require a bigger approach. And so here in the United States in 2014, what's now called the National Feral Swine Management Program was initiated. And that was a huge deal that Congress has approved funding for this program. And so they're responsible for managing the pigs now here in the United States. And they support both operational activities, but also research in all the different areas of research that can be done. And they're doing a great job. And we're very glad that Congress saw fit that we would have such a program here in the United States. But I guess the point is that it's not the only, these tools that we have available just aren't going to get us there in the end. And so this webinar is about fertility control and its place, where it might fit in the management of wild boar or feral swine or wherever you are and whatever we're trying to manage. And so some of you have probably seen this before. This is kind of an idealized graph showing what can be done with fertility control. Now, can you see the pointer at all? Probably not.
I don't think so, Doug.
Okay, that's unfortunate. So can you see it there? No. Okay. Anyway, okay. So I'll just talk through these. That's fine. So in the graph on the right, you can see we start with a number of animals. And again, this is kind of idealized. And I would say this was kind of the idealized model for a closed population. And that was talked about earlier in the webinar as well, as opposed to an open population. So we start with a number of animals. And in this situation, some kind of control is done. And so it decreases that population significantly in a short amount of time. But as we can see in the dotted line, with the conventional controls, that population can recover relatively quickly. And it does depend on the species. But if we were to combine that control with a fertility control, it has the potential to extend the time that it takes for those animals to recover, that population that's being managed to recover. And so the horizontal dashed line represents a threshold. And that threshold has to be considered and has to be figured out for whatever the context is of what that management operation is for. And so that could be, are we trying to manage damage? Are we trying to manage disease? Or whatever that might be. And so that threshold can change, and it will kind of dictate how fast we get to or below that threshold, or whether we never will get there. Okay, and so that's really an important aspect of fertility control and this integrated approach, is that we need to figure out what that threshold is. What is it what is the goal of management that we need to find that threshold or get below that threshold? And so the idea of fertility control has been around for a long time, and some of the advantages are listed on the left. So we can reduce the frequency and cost of control if we get the right tool in place. There's no bioaccumulation. That's a concern for some of the toxicants that are used for different species. There would be a reduced risk to the non-targets. And so we talk about species specificity, and I believe that fertility control offers some of that species specificity, or can do anyway. Because it would be an integrated approach, we could perhaps increase the scale of management from maybe a small population to a landscape scale, and that's a big challenge in itself. And because it's non-lethal, it's often considered to be more humane to the target species that are being managed. And so there are very distinct advantages and benefits of fertility control and using it in an integrated manner. So fertility control, it has a place, but it's hard, right? There's a lot of pieces that go into it. And at the top left, you can see kind of the research that was talked about today. We need to identify some aspect of the physiology, some molecular target that will impact reproduction. And we've looked at hormones, growth factors, blocking fertilization. Those sorts of things have been explored, and we're exploring new avenues as well. And we heard some of that from Jason Bremer earlier about some of the new things that are coming online. And so the second part of that then is the delivery. So we have something that we think will do the trick. Then how do you deliver that to the target species in all the different habitats and all the different conditions where they can be found? And delivery is a huge challenge. And I've broken out kind of 3 different aspects of delivery. And again, that's kind of oversimplified because it is such a huge challenge. But we can look at the gut physiology, kind of the physiology of trying to deliver something, whether it's a vaccine, the immunology, there's the formulation, there's the manufacturing, is it scalable, all those sorts of things. You need to look at how you're going to impact the physiology. Is this a vaccine? Are we going to utilize the immune system, or is this going to be a direct acting agent that doesn't require the immune system? And then we've also talked about the mode of delivery. Is this a non-transmissible form? For instance, the injectables that we have now, or it could be an oral bait that we can put out onto the landscape where the animals can eat that bait and be treated or affected. Or we've also talked about transmissible systems, vectors. Back in the 80s, Hugh Tyndall Biscoe first introduced the idea of virally vectored immunocontraception. So utilizing viruses to spread a fertility control through a population. When I was in New Zealand, we talked about utilizing a gut nematode for a similar purpose in the brush-tailed possums. As those technologies and those methods were being refined and developed, it became very clear that there was a social component to the use of a transmissible form that was just not acceptable at the time. But I think we continue to kind of push the technologies and understand them better. So I'm quite certain that the idea of a transmissible form of fertility control will always be there. And we might get to a point where we start entertaining that even more. But there's a huge challenge in that as well, like I say, that social component. And so once we get these things together, then there's all the testing and the refinement of whatever this potential thing is. And we heard about earlier about modeling. So how would this get incorporated? What would it do or potentially do? the first day we heard about the social science, the ethics of this. And then just prior to me, we heard from Jeanette about the regulatory aspects. So all of these are challenges in themselves, not insurmountable, but they certainly are, and they all take time. And then you can see the arrows indicate that this is an iterative process. And so we just keep refining and until in the end, we're hoping that those new management tools will become available. Now, I mentioned that the delivery is such a huge challenge. When I was in New Zealand, a woman named Susan Marks put together a really clever cartoon. And this was for the possums. And wouldn't it be nice if we could just set up a little shop and put a sign up and all the animals just come in diligently and receive their treatment. But that's not going to happen. And so there we're left with all those challenges that I've mentioned before around the delivery. But we have developed management tools, and we will continue to develop new management tools as we go along. And I'm encouraged by the fact that the idea is still there, and I think different areas of potential funding and different governments are certainly more and more enthused, I guess I could say, about the idea of incorporating fertility control. It will take a lot more funding than we've received so far, but again, I'm encouraged that we will get there, and more money will come for this. And so we've heard talk about what's the goal. And Kurt brought this up, and I guess Jason and others have as well. One hit permanent sterility. That's always kind of been my motto in the work that I've been doing in working in a number of different species. For me, for the wild boar or the feral swine, and particularly the feral swine where they're invasive and non-native, we really need that one hit permanent sterility. Certainly on a landscape scale, to be able to get to all of as many animals as we can, we'll kind of have one shot. If we don't do the job getting to that one time, the chances of getting to them again will become that much more difficult. And I think, Gio gave her presentation on the work that we've been doing in Hong Kong with the wild boar there. And that case is made very clear to us, where we're using an injectable, bringing those pigs in once, fine, we can give them an injection, but finding those animals again is very difficult. And so I believe that this one hit permanent sterility, certainly in the context of the invasive species we have here, is imperative. But again, that's something that needs to be discussed in whatever part of the world they might be being managed. And then we have the different criteria that have been brought up before for what an acceptable fertility control might be. Of course, it has to be effective. It needs to be humane. It needs to be safe for the environment, so it doesn't bioaccumulate, those sorts of things. People talk about species specificity, and that's a difficult one. So physiologically, that's quite difficult. There's a lot of redundant kind of proteins or factors that are involved in reproduction in mammals. But as we've heard also, there's different ways of getting to species specificity, not just through the reagent that we might use, but the way that we deliver it. So for the feral swine here in the States and in Australia, we've seen different, and in the UK, the different forms of specific feeders. So we can add an element of specificity and reduce the number of non-targets that get to that agent. And then of course, everybody's worried about the bottom line. So it does need to be cost effective and whatever that might mean. And so because these are new technologies, these criteria, we're held to these. And sometimes they do become quite a challenge in themselves as well. And so what we want is the ideal fertility control, or I should say maybe fertility controls, because we need as many tools in that toolbox as we possibly can. So the ideal fertility control would be one that's technically feasible. So we have the technology and the ways of creating that reagent that we might use, but then it also has to be acceptable to the end users in that it's effective and cost effective, but also to the public. So there's that social element as well. And so The ideal fertility control is what we propose, I guess, as managers and as scientists, plus any justified differences. And so how do we deal with those justified differences, and what might comprise those justified differences as well? So we can think about the consequences. So if we put this out there, what would be the consequences or potential consequences, and do the benefits outweigh any harm that they might do? We as society, we talk a lot about rights and what can and can't be done. And there are times when there's certain things that just can't be done. And so that will enter into that conversation. And then there's societal virtues, right? What would a good person do, right? And so those sorts of things all become part of that discussion about what those justified differences might be. So in the end, what everybody wants is something that's safe. And of course, safe means different things for many different people. For probably as many people are on this webinar today, we would all have slightly different definitions of what we might consider as safe. And so a colleague of mine in New Zealand, Mark Fisher, in fact, he's the one who first presented this idea of the ideal fertility control. He reminded us that these discussions really shouldn't be so much discussions, but a dialogue. And there's a difference between a dialogue and a discussion, whereas in the dialogue, it's more of a two-way communication. And as we were reminded on the first day, this dialogue will not only involve educating ourselves, understanding things, but it also has a huge component of our values. And that's where the human dimensions side of things comes in as well. What are those values, and what is it that dictates the decisions and where we put value judgments on different things, and what would be acceptable or not? But in the end, again, we want that ideal fertility control or controls, and we want them to be safe. And so we'll come full circle now. The big challenge in front of us is there's too many pigs, and they are intelligent, they are adaptable, and they are highly fecund. But we've also, I believe, made a very good case during this webinar for all the evidence and all the research that's been done. There is most definitely a place for something like fertility control in the management of wild boar and feral swine in the many different places around the world. And we've heard from many different parts of the world where the problems are the same, but they're also different because of where they are and what society thinks and how they deem and where those values are. And I was pleased and I heard when Dave Pauly said, successful management really needs to be realized by an integrated management approach. And we know this, there isn't a single tool that's going to do everything for everybody in every situation. And the tools that we have now, they can be effective in certain contexts, but they're not the answer. And so we need these additional tools to add to that integrated management approach. And fertility control, again, certainly has a place and will continue to be developed and be incorporated as we develop the things and have them available. So with that, I've been at this for a long time, and there's been a lot of people that I've interacted with and have helped me and got to where we are now. Certainly the Fertility Control Project here at the MWRC, but I also wanted to point out, Gio and Polam or Bianca Chan in Hong Kong. So the work that we've been doing with the wild boar there and for this webinar, and acknowledge the good work that we've been able to do. And also, we've learned from the things how hard this is, and not everything's been successful, but that's been useful in itself to know what doesn't work as well. And so, and I also like to thank the Botstiber Institute for Wildlife Fertility Control for sponsoring this webinar series. I think it's been wonderful, and I'm really grateful for all the participation that we've had for this. And with that, I thank you, and I think we'll be ready for some questions.
All right. Doug, thank you. I could not think of a more appropriate presentation to wrap up today and the final day of our series. So thank you so much for that. First, can everybody hear me okay? All right, I'm gonna assume that's yes.
Yes, we hear you. We hear you.
So I will start reading some of the questions that have come in. If you have not submitted a question yet and you want to, please feel free to do so at this time. So this question is for Doug or any of our speakers today. Jason, Gio, Jeanette, heads up. There is the question is, there is a growing need clearly and demand for non-lethal wild pig population control agent for urban, suburban, and special use areas like golf courses, arboretums, properties like that. What can the average citizen, animal control agencies, or private property owners who do not support toxicants do to urge the USDA and other policy and decision makers to prioritize research and development of an oral contraceptive tool to complement and supplement some of these lethal control programs? That was a mouthful, so you can marinate on that for a second before you choose to answer. So
Yeah, that's an important question. It's a good question, and it's a hard one as well, because we've been here for a long time, right? And I think I'll go back to, again, at least here in the United States, it has been recognized that at least the feral swine here are an immense problem, and something needs to be done about it. And so the National Feral Swine Management Program has been established, and they are supporting the research into these new areas. And I would say that, to my understanding, that there are parts of Congress, there's areas of government that really want to see fertility control in these non-lethal methods incorporated. And that's being heard. And so the National Feral Swine Program, Dale Nolte is the head of that. He's hearing that as well, and he's supporting that research. Like I said, I think we always want more money, but we're grateful that that support is there. For the average person, I guess, the first thing that came to my mind was write to your congressman, write to your senator or your representative, and get it on their mind, right? I mean, that's usually the first kind of citizen action that someone can do, is to approach those people and be heard, and make sure that maybe it catches the ear of somebody. The challenge is they'll say, okay, we would love to have that too, but at the moment there aren't a whole lot of tools that would be available, right? And so you have to get not only them, but then you have to get those who might be managing those feral swine on board as well. And I think that's where the cost effectiveness comes in. The injectable tools that we have now probably don't fit very well, right? It would be way too much effort to bring those pigs in. And and there's still, I guess, a lot of dialogue that needs to happen there as to how you might incorporate that in. So I don't know that that's a good answer. That was kind of, maybe I would sound like a politician there, but that's a hard one. And I don't know that there is a right answer to it either, but I'd be happy to hear anybody else who has some thoughts on that.
I'm just wondering, above and beyond what Congress so far has committed to by doing something that was pretty precedent setting back when it was done. I think you said it was 2014 that it began.
Yeah,
right?
that's when it started. Yeah.
Right. I guess piggyback onto something that you just said about need probably for something that's oral as opposed to injectable in most of the contexts, at least here in the United States. So Jason, if you're still with us, a quick question for you, and this is from me, it has not been submitted. It was just something I was thinking about during your presentation that I may have missed. So what is it? I know that there's an ongoing oocyte growth factor study that you're doing on wild horses right now with the Bureau of Land Management. Can you explain again what makes the RNA concept that you were talking about for a wild pig application potentially superior to trying something like the oocyte growth factor concept in pigs?
Yeah, great question.
Does that make sense? What I
Yeah,
just,
it makes perfect sense. And the fact is that they would be doing the same thing. So I'll back up. The growth factors that we're, the vaccine against the growth factors that we're developing for horses have been used in other species, just not in the same way we're doing it. And it would do what we're proposing for the microRNA. It stops that interaction. It stops the oocyte or the egg from talking to the support cells in the follicle.
okay.
The microRNA that I suggested for use in the pigs would have a similar content in horses and others. And so neither one of these would be limited to just the species we're using them in now. So I would see that this microRNA that we've proposed to use in the pig might also work in horses or almost any other species. But the pig right now would be the, you know, it's good proof of concept. We know that that microRNA exists. We've got its sequence, and that's just kind of where we started there. So
Okay.
they do the same thing. They just, one blocks the communication by binding it to an antibody. The other one basically blocks it from actually connecting to what it's supposed to connect to by not letting it be there. If that makes any sense.
I was wondering if either of them had potential, a potential oral application down the road, or if you're just thinking in terms of an injectable for either of those.
Oh, I think they.
Horses injectable is logistically feasible, whereas for wild pigs, injectable, depending on the context, may not be.
Yeah. That's a really good question. That's about 2 steps away from either one of
Okay.
these. But
Okay.
I do think there's an opportunity for orals in both of those. And because of the potential specificity, that's really what we have to watch out for the horse one, right? Make sure that what we put out doesn't necessarily work in elk and deer and pronghorn sheep and anything else that they don't want to contracept.
Got it.
And so, yeah, we are definitely thinking about that. We're just not there yet.
Okay, that's very good answer to my just general question about that. To Jeanette's point, what are the next steps in that pipeline that you're thinking ahead of before you start with the concept itself, just to see if it brings about the desired effect? Is 2 steps down the road, yeah, but would we only be able to inject it, or is it possible it could be injectable, or it could be delivered orally at the end of just figuring out if it would do what you were intending it for it to do in the first place? So,
Yeah, I might add in there, you know, the oral delivery, well, that's a huge challenge anyway. And we've been investigating oral vaccines. We know that's hard, right? And we know that, I think even in human medicine, wouldn't we love to be able to go in and just take a pill instead of get a shot, right? And so we know that that technology is hard. We don't know so much about these nucleotide type molecules, how hard or easy they might be. And so, but we are thinking about that. But one would be targeting, again, the immune system, and the other would be what I kind of call the direct acting. So they're quite different in that aspect, very different actually, in how you might approach an oral delivery for either of those.
Right. I'm checking to see if we've had any other questions come in, and so far we have not. We've got about 10 or 15 more minutes. Hold on, I may have. Gio wants to add something to what you said, Doug, but for some reason her video is being blocked. So maybe Rachel can help her out with that. If not, Gio, do you want to try and submit your Q&A? Oh, there she is. Okay, go ahead.
Yeah.
There you are.
Okay. Yes, I just wanted to add something to what Doug said about answering the first question to somebody that was asking what could the normal citizen do to push research or development in this area. And I think in this instance, the Botstiber has a giant role to play in raising awareness of fertility control, but also of the fact that at least in Europe, we don't have any alternative. The only alternative, which is killing, clearly is not working and will not work in the future, which is why, because the hunters that are the main cause of mortality of wild boar are declining and they're not going to increase. So we need alternatives, and the only credible alternative is fertility control, even if it costs millions.
Right. Right. Well, maybe to your point, we don't claim to have all the answers on how to do that, but we have had a lot of participants. I think this is one of the most the most well-attended webinars and webinar series we've had thus far as an institute. So that's been absolutely fantastic. And for participants that are still tuning in and listening to what we're saying, if you have ideas from your respective countries, counties, territories on things that the Institute could do to raise awareness with decision makers, policy makers in your respective areas on the importance of developing additional tools, specifically fertility control tools to complement, supplement the current tools that are available to wildlife managers around the world, we'd be open to ideas. So feel free to write to us. I think that the general info email is BIWFC@botstiber.org. You can also find it on our website at wildlifefertilitycontrol.org. So thank you for that, Gio. I appreciate you mentioning that.
Stephanie Jeanette has her hand raised.
Okay, Jeanette, go ahead.
Yes, hi. So I just wanted to add on to that, those comments so far too from Doug and Gio, because the other thing also to think about is not just Congress, but also the state agencies, because there are regulations in place in some states. I haven't really kept up on that, but I know initially when wildlife contraceptives were becoming a reality, there were a lot of state game and fish regulations that regulated what could and couldn't be done in each state. So that's going to be on a state by state basis, but there might be some opportunities to reach out in those arenas as well.
Now, do you want to say there are some people that are participating that may not be aware that once a pesticide is registered by the EPA, that in order to be used in individual states, there's a process for getting it registered at that level. I'm assuming you have knowledge of that. Do you want to talk a little bit about that? Because I'm not sure that was included in your presentation, but it may be of interest to some folks that are participating today.
Yes, sure, absolutely. Yeah, I can't turn my video on either, but that's okay. Yeah, so yes, that is correct. EPA does register the pesticides first, and then in each state, they also have to be registered. Now that process varies from being pretty easy in some states to being quite complicated. California, for example, requires a lot more. They want to actually see the data. They don't accept, I won't say they don't accept, but they want to do their own reviews. And other states will just defer to, if EPA is registered, that they don't have any specific concerns in their states, they could register it maybe in a few weeks. But other states, California, New York, Florida, have a much more in-depth process. So that's part of it. And then the other part is what's allowed in states that's not a pesticide regulation, but what the state game and fish agencies and their interpretation of what they are comfortable with in each state. And so there are regulations in terms that maybe it's only allowed for research or other things.
Right. So that means that in some states, before registering it, which is, I think, typically done by the agriculture department in a state.
Yes, that's correct. Yep.
If it's for a wildlife species, they will often, I won't say defer, but at least consult with the state wildlife agency before making a determination.
Yeah, that's correct. And again, it's state by state, but I having worked for the Department of Agriculture in Texas, yes, that does happen. And I think that's not uncommon. I think all the state agencies, I think, tend to work together pretty closely. So yeah, so that would happen in consultation, I think, in most cases with the state game and fish agencies.
Okay, and then Jeanette, Gio has a question for you. Gio, do you want me to ask her or do you ask her?
I can, Jeanette, can you hear me?
Yes.
I haven't spoken to you for a while. Hello.
Hello.
I was wondering, how far are we from harmonization between at least US and Europe in terms of if something is registered in the US, would it be then easier to register in Europe, or we have to start all over again?
Yeah, so I think we're quite a ways away, to be honest, for in all practical purposes. There are certain data requirements that are easily harmonized, like the acute tox studies, the 6-pack. Those are very, if the guidelines between the OECD guidelines and EPA's OPPTS guidelines are the same, then that data will, I think, transfer between the US and European countries and other countries easily. But if there's any difference, my experience has been that EPA wants it done their way, right? So, and sometimes there's enough, they may not be identical, but they're not in conflict with each other. So, and I think, we'll get there eventually, but just as an example, we had to do a study. It was an immunotox study, and OECD guidelines and allowed the use of either the traditional sheep red blood cells as a, and then or KLH. Well, EPA only allows sheep red blood cells, so we literally had to go find another lab that could do that study for us. So, and that's only been in the last couple of years. So I think we're quite a ways away, unfortunately, to having that kind of exchange and practical purposes.
Okay.
Thank you.
We have just a little more than 5 minutes left. So if there's anybody out there that has a question, this would be a good time to submit it. But in the meantime, Monique, do you want to at least start wrapping up?
Okay. Well, as Stephanie mentioned, this was a very successful webinar series. It was very well attended, and we're very happy that all of our sessions have been recorded so that they will be posted on the Botstiber Institute's website, wildlifefertilitycontrol.org. And I think it's a very comprehensive and informative webinar series on just what we said, the wild pig issues and the potential for wildlife fertility control. So I just want to thank everyone. Feel free to contact the Botstiber Institute to follow up with any questions you may have after we end the webinar. You can do so BIWFC at botstiber.org. And I want to thank the staff who helped organize this series, and of course all of the presenters over the 3 weeks who contributed their time and their valuable expertise to us. I'm checking one last time. Stephanie, would you like to add anything to that?
Well, just to thank some of the folks that helped organize this above and beyond the Botstiber staff. And that was Gio, Doug, and Jason, who are all with us today and were our speakers on our final day. Thank you so much. We could not have done this without you. And of course, we could not, it would not have been as successful without the high level of participation. So thank you to everyone that tuned in. I hope you learned a lot. I certainly did. And I think everyone did as well. And again, really strongly encourage you to let us know. Number one, if there's anything that we can be doing on this issue with respect to wild pig fertility control in the future that might be of help. That's what we're here for, to serve as a catalyst and sort of a clearinghouse for the wildlife fertility control field. But also, if there are other topics, contexts in wildlife fertility control that you'd like us to bring to the public's attention in the future. It doesn't not have to be wild pigs. So if something else in your area is of interest to you that you think you might want to bring to our attention, please feel free to do so.
Okay. I don't think I see any additional questions.
Nope.
So I think we've concluded our webinar series. And thank you to all the attendees who participated. And with that, we're right on time to conclude. So thank you, everyone.
Take care.
Take care.
All right. Thank
Bye-bye.
you.